This is a demo model for Marconi on Worldwide DX, who I've been having quite a few modeling discussions with. It's quite apparent that how we do things are very different from one another, and this is more or less to show him what it is I do when I model. Um, I'm going to start off right here. This is going to be the file that my model is stored in, LLDemo, linear load demo. If I open up in Notepad, as we can see, it is completely empty, so we're starting completely from scratch. We go into modeling software, and here's the base screen. Now, something Marconi that we've been talking about is auto segmentation, and as you can see, I have something called auto segmentation. The only option it gives me, unlike your EasyNet, is how many segments per half wavelength. That's all I get. I can put 50, I can put 10, I can put 200. Whatever's in here is going to override the data file later, which is why you see me using a lot of one segment length wires. It's not that there's one segment, it's that data gets overridden anyway, so I don't see why I should figure out how many is going to be there. We're going to open up our editor window, go into frequency ground. We're going to set that 27.2 will work. Let's go to real ground. Moderate's fine for this. And save. Okay. Now when I start modeling, I don't put in a lot of wire data like you do. I go into symbols here, and I can go R equals 0.006. I can go over here and comment radius. And then everywhere I put R will be replaced with 0.006. I'll also go, yeah, this does this. Antenna height, say AH equals 11.0. Ooh, wait a second. Did this not? There we go. AH. .02. Oops, it's supposed to be a point. Where did I get that 11.02 from? Wavelength up here in the corner. 11.02, that's the wavelength that we're at. Antenna height, one wavelength. Now, putting variables such as this in late, I can then later go in and say put it at a half wavelength height very easily and adjust the whole antenna instead of just one part of it. Let's see, AL equals 0.02 times 0.625. Antenna length. One wavelength times 0.625, or 5/8. I'm going to put RL, radial length, equals 0.02 times 0.25. Now, in some of my models, we've noted that the radials are actually offset 45 degrees from the X and Y axes. The next part I'm doing is simply putting in a few formulas so I can get that data as needed in the model. So we're going to go RLC, RLC1 equals RL times, RL squared RLC2 equals RLC1 / 2. Oops. It's supposed to be a C. Well. Apparently my typing isn't working very well today. Oops, yeah, 3 equals RLC to the 0.5. I'm just going to call it 0.5. Essentially what I'm doing is the Pythagorean theorem used in trigonometry to figure out where the points need to be. Now I can use the RLC3 variable, and I can use that to position how the radials end up being. So we now have wire 1, tag 1, segment 1. Like I said, with auto segmentation, it doesn't matter what I put in segments. I'm going to go RLC3, RLC3, AH, 0, 0, AH. One side is the tip of the radial, the other side, the 0, 0 side, is the center point where they're going to come together. And of course, R is the radius. Wire, tag 2, RLC 3 minus RLC 3 AH 0 0 AH R. Now if we pop into here, I might have to find it. There it is. We have two of the radials. And if we take these and look straight down, we can see it's 45 degrees offset from the X and Y axis, which is what I was looking to do with them. Wire 3, segments 1, minus RLC, minus RLC, oops, AH, 0, 0, AH, R. Wire 4, minus RLC 3, RLC 3, AH, R. And now if we click into here, we have full set of radials 45 degrees off of the axis. To be expected. Okay, I'm going to make one more little separator equals 0.11. This is essentially what the length of one segment is at this, or very close to it for this frequency. That's all that is. Can't spell today either. Go back into geometry. Now we're going to go to wire 5, 0, 0, AH, oops, AH plus S. Oops. R. Now, click in here, we'll see the little thing coming up. For the linear loading model, this is actually going to be my feed point. So I'm going to go into source, voltage, tag, I think it's 5 actually, segment 1. If I don't touch any of the rest of these, I don't want this in here. If I don't touch any of the rest of those will pop in. Go ahead and save that to the data we need anyway. Okay, now we're going to start on the linear loading section. What happened? Oh, because I don't have all that in. The linear loading section is going to start at the top of this little separator wire. It is going to go along the x-axis back and forth once, and then meet again in the middle. So we're going to go to wire number 6. Starts with H plus S. We need a linear loading equals 1. That's the LL variable for linear loading is going to decide how big the linear loading section is. So go back into geometry. I'm going to go into here, and it's going to go to H plus S R. If I click over here, we'll see we have half of it made. Wire 7, segment 1. We have linear loading section 0, H plus S. Linear loading length 0, AH plus S plus S. Now this should put the little side up just like that. Now we're going to do the one going across. Minus LL 0 R. And we have the piece going back, and that's all I do is build my models one wire at a time using the variables that I set up. Minus LL AH, actually minus add another plus S. We're going to give that the same radius everything else has for now. And number 10. We do that. Now we have the linear loaded section completely made. Now it's a matter of going to figuring out the antenna height or antenna length. So now we have the last element. We have antenna height plus antenna length variables R. Into here, and that's what we have. We're going to save this. Now, one thing we're going to do, you'll note I had one segment for everything. If I show segments, I have more segments in here. That's what auto segmentation is doing. I don't have, even though it says one segment, as we can clearly see, there are multiple segments in play here. I'm going to turn that off for now and give this a quick initial run. Oh, did I not put that data in? I thought I did. Or did I need that real 1, imaginary 0? All right. I didn't do this to give us a plot. I just did this to make sure it'll run without giving any errors. As we can see, our standing wave ratio is kind of high. Something I've recently started doing is using the optimizer. So we're going to go in the optimizer. This is what the optimizer window looks like. As we can see, the SWR is 100% of everything that's here. I can go for efficiency. I can go for any number of variables. I'm simply going to use SWR for this. The variable I'm going to use is LL, which is the one that determines how big the linear loading section is. I'm going to click Start. And as it works, we can see the standing wave ratio change as it slowly drops. Got to 1.31. I think it can do better. Resume. So it doesn't want to do better. Let's give it one more try here. Okay. That may be as good as it gets. We're going to update that back to the NEC file. This model didn't even the one I used earlier did not get 100% perfect SWR. So, and I wouldn't expect it to. It's more like using a loading coil than a full matching system. And we're going to go in a little further. Average gain test. Right here, AGT results of 0.9. That's a bit below what I like. A bit below what is considered accurate. I have an AGT file here down to, says it's usable for most purposes. I think we can do better, however. So how do I adjust this? There's two things I will do with on a model like this. The separator variable that we used before. Let's change that. .909. Oops. .915. So we're getting better. And all I'm doing is changing the separator used here. It's not something I like to do a lot. Some models I need it. Some models are just more accurate with a different size separator, depending on what it is I'm doing. I'll also change the segmentation on this. But we're up to 9.15. I will, oops, not the optimizer. I'm awake. Oops. .21. .26. Let's see if we can go a little faster up. Let's go all the way up to 0.2. .983, that's much better. But I also have much larger separators. If I go into segments and I zoom in, we now have 3 segments for each of those, which is fine. But we're also much higher SWR, so we need to optimize it again. Oops. Do it one more time. Update an EC file. Okay, now we have a file that we can look at. Far field pattern, turn average gain test off. To what I'm showing on an antenna that's 1 wavelength above ground. We can also go in and frequency sweep. Let's do, this will be a little off the center of the, but it'll be close enough. And we have SWR, gain over that range, impedance. We can also turn it off. We can do various things in here as well. There's also a few other things I tend to look at. Sometimes when I'm working with the average gain test, I will have to go in and actually change the segment count slightly. I try to keep it between 40 and 60. See what we're at now with these changes. 9.979, which if we go into my reference here, is between 0.95 and 1.05. The model is likely to be accurate. That's essentially what I do when it comes to modeling. Really not much more. This type of modeling allows me a lot of adjustments. If I want to make it longer, antenna length. I simply put it here and it modifies the length of the antenna. Say I want to put it at 5 meters above ground. H equals 5. You'll see in here it dropped it down. I'm now 5 meters above ground instead of 11.02 meters. I can, that's all the variables do. But like I said before, the auto segmentation that you were concerned about, it says one segment, but when you look at the model, the actual segments on the model that gets run, it's not one segment. It's whatever the auto segmentation was set to. To give you the exact number so you can enter them into EasyNet, I'd actually have to go through and count them. Or I could do a calculation and get close. This one will have a little under 60, I would guess. 1, 2, 3, 4, 5, 6, 7, 8, 9. Probably 50, 54. That's a guess, but that's what I have. That's how I do it. That's how I do all my models nowadays. If you have any questions, feel free to ask, Eddie.